solve Leetcode problem 2320, count number of ways to place houses. So let's first try to understand the second example, because this n equals to 2 and there are more different cases. So this is similar like the house robbing problem. Yeah, let's just try to analyze how many different ways. So yeah, we're gonna return the number of ways houses can be placed such that no two houses are adjacent to each other. So as you can see, no two houses are adjacent to each other. So this is gonna be a house robbing problem. Yeah, we just need to find how many ways. So for example, so if this n equals to 2, yeah, so if n equal to 2, what's gonna happen? So we can, so the house at the upside and the downside is going to be independent. It means it doesn't matter. So I can only choose one side. So if the upside, the width is the result width, so I just need to use the result times the result. Yeah, because the upside and the downside are independent. If there are result width of upside, definitely there will be result width of downside, and then we can combine them together. So we can use the multiplication to combine them together. Yeah. And if n equal to 2, so we only consider the upside. We will not place any house like this one. Or we can just put let's just analyze this one. Yeah, or we can just place one house at this place. Yeah, or we can place another house at this place. But definitely this at the right side, or this is the left side. This is the index 0 and this is the index 1. Definitely at the upside there's no two houses are adjacent. Yeah, and then we're gonna choose all other different ways. So for example, if this is empty, how many different ways? As you can see, 1, 2, 3. So upside is empty, this is empty, this is empty, this is empty, it is the 3. So for all others it's the same. So that is why we can use 3 times 3 to get the result. So the problem becomes, how can we calculate at one side? So for the upside, how can we calculate it? So we can use the house robbing problem to solve it. So for house robbing, we can decide each of the places, we can decide whether we're gonna rob it or not. And then we're gonna calculate how many different ways. So for example, there are two slots, 0 and 1. We can decide to rob it. If we decide to rob it, yeah, so for example, it is a 1, we decided to rob it. And for the second one, it must be not rob it because it cannot be adjacent. Yeah. Or we can decide if we are not rob it. So for the second case, it's going to be 0. We will not rob it, or we can rob it. So how many different ways? So there are 3 different ways. So according to this kind of formula, we can write the dynamic programming to solve the problem. So for me, I'm going to use a class plus DFS to solve the problem. So I'm going to starting from index I, and I'm going to use a rob to check for the ice house. So for the ice house, so this is DFS means for the ice house, did I rob it or not? If this rob is true, it means I robbed the ice house. If rob is false, it means I didn't rob the ice house. The final result would be DFS. I'm gonna starting from index 1. Yeah, so I can start from index I can start from index 0, and with true, this means the index 0, the first house is robbed. I robbed the first house, and I can plus the DFS with 0 false. This means I didn't rob the ice house. And the final result would be modular a mod. And we can prepare the mod is 10 to the power of 9 plus 7. Now we can decide how to rob it. As this is the first way, we've already robbed or not robbed the first house. So we're gonna start from the second. So it means from here, we can use this I equal to n minus 1. Definitely we're gonna use I equal to n, but here we've already robbed the first house or not robbed the first house. We've already dealt with the first house, so we're gonna just need to tag n minus 1. So if this I equals to n minus 1, this means we finished one solution. It's gonna be 1. And then we're gonna check the rob. If I rob this house, definitely I'm gonna prepare a result. Result would be different way. How many different ways? So it's gonna be result plus equal to DFS. So if I rob the i's, if I rob the i's house, so for the next one, can I rob it? Definitely I cannot rob it, so it's gonna be not rob for the next one. Else, if I didn't rob the ice house, so for the next one, it's gonna be two different ways. Maybe I don't need to write this. I just need to have a return. I think return is enough. So I'm gonna return this way. Otherwise, I'm gonna return another way. So it's gonna be I plus 1. For the next one, I can rob it because currently I didn't rob. So for the next one, I can rob it, or I can decide not to rob it. So it's gonna be not rob. Maybe I gonna use a result. Maybe this is better. So result would be equal to 0, and here gonna be result plus equal to this one, and else result plus equal to this one. And finally, I'm gonna return a result modular a mod. I think it's the same way, but let's just have a check. What happens? Yn equals 1, I got a 2. Because it is not plus, I think it is a multiplication. It is I need to take it inside a result. So I'm gonna prepare a result, because result should be equal to this number. Because this result is just from one side, I need to combine all different cases. So it's gonna be result times the result modular a mod. So this is gonna be the final result. Let me just have a check. Y it's not divided, it's a modular a mod. Now let's say it seems everything is okay. Let me just submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. Although it is much slower, but I still think DFS plus memorization is a better way to solve the problem from the beginning. If you are familiar with the memorization, maybe you can start to try the tabulation. The tabulation definitely gonna be much faster than this one. Thank you for watching. See you next time.